So it's 7:07 a.m. We're in the remote Siberian taiga, and the date is June 30th, 1908.
Right. Just a completely normal, freezing subarctic morning.
Exactly. Just picture the absolute stillness of that. And there's this local merchant. He's just sitting quietly on the porch of a trading post, finishing his breakfast.
Mm-hmm.
And then, literally without any warning whatsoever, the sky just violently splits in two.
Yeah, it just tears right open.
Right, and this blinding bluish-white second sun just appears right above the tree line. And before he can even, process the light, this invisible wall of radiant heat slams into him.
It's so intense that he literally believes his shirt has spontaneously caught fire.
Yes. So he goes to tear his clothes off, right? But before his hands can even reach his collar, the sky just seems to slam shut, and this invisible hammer of compressed air throws him several meters into the dirt.
And then the earth starts to heave.
Yeah, he just covers his head, absolutely certain that the world is ending.
And, that sheer visceral terror is exactly what makes this event so captivating to study.
Oh, absolutely.
Because you have this really profound collision between the very limits of human endurance and the cold, unyielding mechanics of astrophysics.
Because what that merchant experienced wasn't the apocalypse, even though, it totally felt like it. It was the Tunguska event.
The largest impact event in recorded human history.
Exactly. And today, for this deep dive, our mission is to examine the massive trove of Wikipedia source material on this disaster.
Which is extensive, to say the least.
It really is. And, we are sitting here on April 16th, 2026, which means we have well over a century of scientific investigation to sift through for you.
Right.
We're going to explore not just the terrifying reality of what happened that morning, but really how generations of scientists have spent the last 100+ years trying to solve, the ultimate locked room mystery.
I love that framing, because it really is.
It is. It's a crime scene covering hundreds of square miles, but there's no murder weapon, and this is the crazy part, no crater.
It is the absolute definition of a scientific paradox.
Yeah.
I mean, you have an explosion that unleashes the energy of a modern nuclear arsenal.
Right.
It flattens 830 square miles of dense forest, millions of trees just knocked over, and yet the planet essentially swallowed the evidence.
It's wild. But let's stay in that morning for a moment. Because to understand the physics, you first really have to understand the human data points.
Right, the eyewitnesses.
Yeah, so we are looking at the area near the Podkamanaya-Tunguska River, which is northwest of Lake Baikal.
Which is an incredibly unforgiving, sparsely populated region.
Extremely. But there were indigenous Evenki people living there, and there were some Russian settlers.
And their testimonies are critical because they didn't just, hear a distant boom.
No, they definitely did not.
They experienced a multisensory overload that completely defied anything in their frame of reference.
Right. So going back to that merchant on his porch, that is the account of S. Semenov at the Vanavara trading post.
Mm-hmm.
And the terrifying part is that Semenov was 65 kilometers away from the epicenter.
Which is a massive distance.
Think about that. If you are standing in downtown Manhattan, 65 kilometers away puts you, deep into New Jersey or way out on Long Island.
Right.
And from that far away, the thermal radiation was so intense, it felt like his skin was combusting.
And notice the specific details that modern physicists extract from his panic. Semenov estimated the fire was about 50 degrees up in the sky.
Okay.
So it wasn't just a flash on the horizon. It was looming directly over the landscape.
Wow, yeah.
And that intense burst of thermal radiation arriving before the shock wave, that's a vital piece of the puzzle. Because light and heat travel much faster than the kinetic pressure wave.
Right, the speed of light versus the speed of sound.
Yeah.
And when that pressure wave finally hit him, it physically threw him across the yard.
Yeah.
When he came to, he reported a noise like rocks falling or cannons firing. He actually pressed his head into the dirt because he thought falling boulders were going to smash his skull.
Just absolute panic.
But as bad as Semenov had it, the accounts from people closer to ground zero are just... they're harrowing.
You're referring to the Evangeki accounts here.
Yeah, specifically Churchan of the Shanyagar tribe. He and his brother Chekrin were sleeping in their hut by the river, significantly closer to the blast.
Right in the danger zone.
Yeah, and they wake up to this sudden whistling wind, and they can hear birds flying overhead in the dark.
Which is such an eerie detail.
It really is. Just the wildlife panicking before the humans even know what's happening. And then the physical displacement hits. Churyan gets shoved so hard he falls directly into his own campfire.
Because the structural devastation at their proximity is just Total. The wind simply erases their hut.
Yeah, it's just gone.
He's pinned under the sticks and the debris.
And he manages to look up, right, and he sees the forest itself falling down around him. Branches are instantly catching fire.
Wow.
And he describes that, quote, second sun that makes his eyes ache. And following the light, he hears a succession of thunders. Not one bang.
Right, that's the key.
He hears a loud thunderclap, then another flash, a third thunder, a fourth.
And that auditory complexity is something that shows up again and again in the regional reports.
Yeah, the newspapers.
Exactly. If you look at the newspapers from the surrounding towns in the days that followed, and these are places hundreds of kilometers away, they weren't reporting a single explosion.
Right. The Saibar newspaper on July 2nd, they reported peasants seeing a cylinder-shaped, bluish-white body moving downwards for 10 minutes.
10 whole minutes.
Yeah, and they said it smudged into a giant billow of black smoke, and people literally took to the streets weeping, convinced it was Judgment Day.
And the Siberian Life and Krasnoyared's papers described the sound as being like a railway with dozens of trains traveling simultaneously.
Like dozens of trains.
Yeah, followed by 50 to 60 distinct artillery salvos. It was a sustained, rolling roar of concussions.
But, I have to play devil's advocate here for a second.
Yeah, for it.
If you ask 5 people at an intersection about a fender bender, you get 5 completely contradictory stories about who had the right of way.
Oh, absolutely.
And here we are dealing with isolated people experiencing trauma-induced memories of what they thought was the literal end of the world. Are scientists seriously using these panicked memories as hard data?
It's a completely fair skepticism.
Yeah.
I mean, trauma famously distorts temporal and granular details.
Right.
The exact duration of the light, the specific hue of the blue or red in the sky, those elements blur.
Naturally.
But what forensic scientists look for in these historical accounts is macroscopic consistency across isolated populations.
Okay, so finding the overlap in the Venn diagram of trauma.
Precisely. The Evenki hunters had absolutely no communication with the Russian merchants at the trading post.
Right.
And neither group had contact with the journalists in regional towns hundreds of miles away. Yet a rock-solid, corroborated data set emerges from all of them.
Because they all report the same sequence of events.
Exactly. They all report radiant heat preceding the shockwave.
Yeah.
They all report the high-altitude visual of a splitting sky, and they all consistently describe those sequential rolling concussions. That multi-source consistency gives modern supercomputer models a highly reliable foundation.
So if everyone says it felt like a second sun from 50 miles away, it absolutely put out the thermal energy of a second sun.
Exactly.
Now, if this were just a localized disaster, it probably would have remained a Siberian myth. But the planet itself felt this blow. The Earth literally rang like a bell.
Oh, the global echoes of Tunguska are staggering, especially when you consider the rudimentary state of scientific instrumentation in 1908.
Yeah, they didn't have digital sensors, but the blast registered on seismic stations across all of Eurasia. And it wasn't just the ground shaking, right? It was the sky itself. Atmospheric air pressure waves were detected in Germany, Denmark, Croatia, the UK.
They measured the displacement all the way in Batavia in the Dutch East Indies.
Right, and it visibly moved the needles on barographs in Washington, D.C.
Which is just incredible. For an air pressure wave to maintain enough cohesion to travel from central Siberia, cross oceans and continents, and register on analog instruments in Washington.
It's unfathomable.
The initial atmospheric displacement had to be massive. Current estimates place the resulting shock wave hitting the ground as equivalent to a 5.0 on the Richter scale.
A 5.0 earthquake generated entirely by a concussive blast in the sky. That is wild.
Yeah.
But the seismic data isn't even the strangest global effect. You have to look at the bright nights phenomenon.
The noctilucent clouds.
Right. For days after the explosion, the night skies across Asia and Europe glowed so brightly that people didn't need lamps.
It was like daytime.
There are contemporaneous reports of people reading the newspaper outside at midnight in Sweden and Scotland.
Yes.
They were taking highly detailed, brightly lit photographs at midnight without using flashbulbs, just relying on the glowing sky.
And the mechanism behind those glowing skies is really fascinating. It actually served as a secondary mystery for decades.
Oh, really?
Yeah, the prevailing theory now, which modern atmospheric physics supports, is that the light was passing through high-altitude ice particles.
Wait, but where does the ice come from in a giant fire blast?
Right, it sounds contradictory. But the explosion itself propelled an immense volume of water vapor, and pulverized particulate matter straight up.
Straight up into the atmosphere?
Way up, into the mesosphere and thermosphere. That's the extreme upper limits of the atmosphere where temperatures are radically low.
Okay, so it freezes.
Instantly.
Mm.
This vapor froze into microscopic ice crystals. And because these clouds were so unbelievably high up, even when the sun had physically set and it was night on the surface of the Earth, the sun's rays were still hitting those high-altitude ice crystals.
Oh, hey.
Yeah, and reflecting sunlight back down onto the dark side of the planet.
So, if you drop a boulder into a quiet pond, the splash sends water high into the air.
Right.
But in this case, the pond is our entire atmosphere, and the splash is carrying thousands of tons of dust and ice to the very edge of space, wrapping around the globe.
That is exactly the fluid dynamic at play. And we've actually seen this phenomenon reproduced on a micro scale in modern times.
Wait, really?
The exhaust plumes from space shuttles.
Oh.
Yeah, like the Endeavour. They pump massive amounts of water vapor into the thermosphere when they launch, creating artificial glowing clouds that behave exactly like the skies over Europe in 1908.
That is so cool. And, it wasn't just a pretty light show. The Smithsonian Astrophysical Observatory at Mount Wilson in California recorded a massive, months-long decrease in atmospheric transparency.
The dust.
Yeah, they calculated that roughly 1 million tons of dust had been injected into the stratosphere.
And the chemical fallout was equally severe. Shockwaves of that magnitude generate incredible amounts of nitric oxide.
Right.
Atmospheric modeling suggests the blast created up to 30 million tons of it.
3 million tons.
Yeah, resulting in a sudden, severe depletion of the ozone layer. In early 1909, the Northern Hemisphere saw a 35 to 45% drop in ozone.
That's almost half the ozone layer.
Exactly, meaning the ultraviolet radiation hitting the ground in certain latitudes temporarily tripled.
So literally the entire globe is flashing warning signs. Seismographs are jumping, the night sky is glowing, the ozone is tearing, and 1 million tons of dust are blocking the sun.
It was a global alarm bell.
You would assume every geologist and astronomer on Earth would be chartering a train to Siberia the very next day.
But nobody went.
Nobody went. The site sat in total dead silence for over a decade.
It's wild to think about now, but if you look at the geopolitical reality of the early 20th century, the delay is tragic, but entirely logical.
Yeah, timing is everything.
Right, the Podkamennai-Tunguska River Basin is already one of the most hostile, remote taiga environments on the planet. But more importantly, the world was about to catch fire.
Right, 1914.
Exactly. The 1910s brought the devastation of World War I. Then Russia completely collapsed into the Bolshevik Revolution in 1917.
Followed immediately by a brutal civil war.
The nation was fighting for its very survival. Investigating a fallen star in a frozen swamp was simply not on the docket.
Survival absolutely trumps scientific curiosity. So it isn't until 1921 that a Russian mineralogist named Leonid Kulik finally manages to organize a preliminary survey for the Soviet Academy of Sciences. And he doesn't even make it to ground zero on that first trip. But based on the regional accounts he gathers, he becomes fiercely convinced that a gargantuan meteorite caused the blast.
And Kulik is a fascinating historical figure because he weaponizes that conviction to secure funding.
Oh, he was a salesman.
He had to be. The newly formed Soviet government wasn't interested in pure science. They needed resources.
They needed metal.
Right, so Kulik pitches the expedition as a massive salvage operation. He promises them a mountain of meteoric iron sitting in a crater ready to be mined for the state.
He had his entire mental model locked in before he even packed his bags. Big blast equals big space rock equals giant crater full of iron.
A very linear way of thinking.
Exactly. So in 1927, he finally gets the money, hires local Evenki hunters, and they trek into the dead center of the blast zone.
Which was no easy feat.
Not at all. Imagine the physical toll of this journey. They are hacking their way through dense, devastated, swampy taiga surrounded by millions of dead trees.
Yeah.
And they are fully expecting to crest a ridge and look down into, the Grand Canyon of meteorite craters.
And then they reach the coordinates.
They arrive at the exact epicenter, and there is nothing. No crater, no smoking pit, no mountain of iron, just flat, boggy earth.
But what they found instead of a crater completely shattered their understanding of impact physics.
Oh, totally. They found a zone of sheer devastation covering 2,150 square kilometers.
Just massive.
The footprint of the flattened forest was shaped exactly like a gigantic spread-eagled butterfly.
A really specific shape.
Yeah, you have a wingspan of 70 kilometers across and a body length of 55 kilometers. Millions of mature trees all violently pushed over, pointing radially away from the center.
And that butterfly geometry is a critical diagnostic tool that physicists will rely on decades later.
Right.
But the most perplexing discovery was waiting for Kulik at the very heart of that butterfly.
The telegraph poles.
Yes.
This is detail that gives me absolute chills. At the exact epicenter of this apocalyptic blast, the trees were not knocked over.
Which makes no intuitive sense.
Exactly. They were violently scorched, their bark was stripped, every single branch was blown off. But the trunks were left standing perfectly upright.
Just sticking straight out of the ground.
A dead, blackened forest of telegraph poles right at ground zero.
Which fundamentally breaks Kulik's crater theory.
How so?
Well, think about the geometry of an explosion. If a physical rock hits the dirt and detonates, the blast wave moves horizontally outward along the ground.
Okay, yeah.
So everything at the center should be pulverized and thrown outward. A ground burst does not leave trees standing at the point of impact.
Right, if a bomb goes off at your feet, it blows your legs out from under you. It doesn't strip your clothes off and leave you standing.
Exactly. But Kulik was a victim of immense confirmation bias. He couldn't let his Iron Mountain go.
He really couldn't. He spent the next decade of his life chasing ghosts in that swamp. He led 3 more grueling expeditions. He found these small, natural pothole bogs across the landscape, measuring maybe 10 to 50 meters wide, and convinced himself they were microcraters.
Yeah, he spent massive amounts of time and manpower draining one of them, which he named Suslov's Crater.
And what does he find at the bottom after pumping all that water out? An old tree stump.
Just a stump.
It was just a natural Siberian bog. Kulik was seeing craters in the mud because he desperately needed to see them.
And, the tragedy of Kulik's work extends well past his own lifetime. In 1938, he orchestrated an incredible aerial photographic survey of the site.
This part breaks my heart.
They took 1,500 negative photographs covering 250 square kilometers of that leveled forest.
Imagine having that raw, high-resolution visual data.
I know.
But then you read what happened in 1975. Yevgeny Krinov, the chairman of the Committee on Meteorites for the USSR Academy of Sciences, ordered every single one of those original negatives to be burned.
And the justification was purely administrative.
It's so frustrating.
The negatives were printed on early, highly flammable nitrate film. So Krinov ordered them destroyed as a fire hazard.
It is physically painful to read. They burned the most comprehensive visual evidence of the largest impact event in history to prevent a potential filing cabinet fire.
Just bureaucratic logic at its finest.
Thank God positive prints were preserved in Tomsk, but losing the original resolution of the negatives is a massive blow to the historical record.
It is a profound loss. But, even without the negatives, the macroscopic evidence Kulik did document, specifically those standing telegraph poles, eventually pointed scientists toward the only logical conclusion.
Right, because if you apply basic physics to those standing trees, they scream exactly what happened.
Exactly.
If the trees are stripped of their branches but left standing upright, the force had to be moving straight down. It was a vertical crush, not a horizontal push.
Exactly. The tree trunks are structurally evolved to withstand extreme downward compression. That's how they support their own massive weight.
Right, gravity.
But the branches stick out horizontally, and they are weak.
Wow.
So when an explosion happens miles above the forest, the primary blast wave travels straight down.
Okay.
It shears the branches off, but the trunk survives the compression. And as that downward wave finally hits the ground, it deflects horizontally outward.
Oh.
That is when it starts knocking the surrounding forest over, creating that vast radial butterfly pattern.
So the physical evidence is shouting, airburst. But Kulik spent over a decade looking for a smoking gun that didn't exist.
Right.
Because the very concept of a space rock detonating in the atmosphere, like a nuclear bomb, just wasn't part of the scientific vocabulary in the 1920s.
No, not at all. They thought meteors either burned up entirely as pretty shooting stars, or they hit the ground as solid rocks.
So the paradigm had to shift. And it did, right around the 1950s and 60s. The scientific community realized that if the rock vaporized in the air, you aren't going to find boulders.
You have to stop looking at the forest and start looking through a microscope.
Which kicks off the microscopic hunt. Expeditions completely abandoned the search for craters. Instead, they started painstakingly sifting through the soil, pulling core samples from the peat bogs, and examining the dried resin of the surviving trees.
And that transition from the macroscopic to the microscopic yielded immediate, undeniable results.
They found the ash.
Yep.
In siftings of the soil and trapped inside the amber-like tree resin, researchers discovered millions of microscopic silicate and magnetite spheres.
Tiny little glass beads.
Right, and when they ran chemical analyses on these tiny beads, they found incredibly high proportions of nickel relative to iron.
Which is the undisputed fingerprint of the cosmos.
How so?
Terrestrial rocks have specific known ratios of iron to nickel. Meteorites have a distinctly different, highly elevated nickel ratio.
Oh, I see.
So finding those spherules concentrated across the blast zone perfectly matched the theoretical fallout pattern of a mid-air vaporization.
But they didn't stop at the soil. They went deep into the peat bogs. And I love this concept, the idea that peat bogs and tree rings act as these natural high-fidelity hard drives.
They really do. They passively record the exact atmospheric chemistry of the Earth year by year.
They are pristine biological archives. So they drill down to the specific geological layer of the bogs corresponding to the year 1908.
And the chemistry goes completely haywire.
Right. They found massive spikes in anomalous isotopic signatures of carbon, hydrogen, and nitrogen.
And because different regions of the solar system leave distinct isotopic fingerprints in the materials that form there, finding a sudden localized spike of anomalous carbon and nitrogen in that specific 1908 swamp layer.
It's essentially an alien barcode.
Exactly. It proves definitively that millions of tons of material not originating from this Earth were violently introduced into that ecosystem.
And if you know your dinosaur history, you know what they found next.
Iridium.
They found an unusually high proportion of iridium in the bogs, which is the exact same rare element found in the Cretaceous-Paleogene boundary.
Right, the geological layer of ash that marks the asteroid impact that wiped out the dinosaurs.
Because iridium is incredibly rare on the Earth's crust, but asteroids are packed with it.
Furthermore, they determined that the anomalous nitrogen in the bogs was likely deposited in the form of extreme acid rain.
Wait, really?
Yeah, the sheer thermal intensity of the explosion literally cooked the atmospheric nitrogen, creating a toxic rain that showered the devastated forests in the days following the blast.
Wow. Now, we do have to acknowledge the messy reality of the scientific method here. The Wikipedia sources make it clear that this wasn't a flawless, universally accepted victory lap.
Science rarely is. It relies entirely on independent replication.
And some of that replication failed. Certain papers reported finding these incredible carbonaceous chondrite signatures, but when other independent laboratories took their own samples and ran the measurements, they couldn't confirm the results.
That happens all the time.
Some labs failed to replicate the iridium anomalies entirely.
Which forces the scientific community to ask hard questions. Was the original methodology flawed? Were the subsequent samples contaminated by terrestrial mud? It is a constant, rigorous push and pull.
And speaking of terrestrial mud and the desperation to find a smoking gun, we have to talk about John Stone.
Ah, yes. A perfect cautionary tale of wanting a theory to be true just a little too badly.
So a researcher named John Infinitinoff is out at the site, and he finds this large boulder. It's sitting in a place where it mathematically shouldn't be. It looks bizarre, and he immediately plants his flag.
He was so sure.
He suggests, this is it. This is a surviving fragment of the Tunguska meteorite. They literally name it John Stone.
But the rigorous cross-examination of modern science leaves no room for wishful thinking.
Exactly. They take a sample of the quartz in John Stone and subject it to oxygen isotope analysis. And the results completely burst his bubble.
Thoroughly.
The analysis proves definitively that the boulder is just a completely normal terrestrial metamorphic rock of hydrothermal origin.
It was likely pushed up by ancient Siberian volcanic activity. Zero connection to space.
It perfectly illustrates the psychological gravitational pull of a physical object. People wanted a rock they could point to.
Human nature.
But the overwhelming weight of the microscopic evidence, the alien barcode in the isotopes, the nickel-rich spheres in the resin, it all points unequivocally to a rock that ceased to exist before it ever touched the ground.
So if we accept that the rock vaporized in the air, raining down as microscopic ash, how does that happen?
Right.
How does a solid piece of stone weighing millions of tons just spontaneously detonate in the sky?
To understand the mechanics of an airburst, you have to fundamentally change your perception of how the atmosphere behaves when confronted with incomprehensible velocity.
That's the key.
Let's lay out the consensus numbers that modern supercomputers have landed on. The object was an asteroid roughly 50 to 60 meters wide. That's a chunk of rock the size of a 20-story building.
A massive object.
It weighed millions of tons, and it hit our atmosphere traveling at approximately 27 kilometers per second. That is nearly 100,000 kilometers per hour. Mach 80.
And at Mach 80, the fluid dynamics of our atmosphere completely break down.
Right, if you move your hand slowly through a swimming pool, the water easily flows around your fingers.
Yeah.
But if you belly flop off a high dive, the water simply doesn't have the time to move out of your way, and it acts like concrete. At Mach 80, the Earth's atmosphere is that concrete.
That phenomenon is called ram pressure. As this 20-story mountain of rock plunges into the atmosphere, it compresses the air directly in front of it so rapidly and so violently that the air cannot escape.
And basic thermodynamics tells us that when you violently compress a gas, it heats up.
But this isn't just getting warmed from friction.
No.
The compression is so extreme that the air itself fundamentally changes state, becomes a superheated plasma.
Wow.
The asteroid is suddenly pushing a localized shock wave of plasma that is physically hotter than the surface of the sun. The rock begins to melt and ablate immediately.
This is where planetary scientist Christopher Chiba's models come into play, right? Because as the rock gets deeper into the atmosphere, the air gets thicker, and that ram pressure increases exponentially.
Precisely. Chiba's models track a terrifying mathematical equation. You have the immense aerodynamic force of the thick lower atmosphere pushing against the rock, trying to stop it.
Okay.
And you have the cohesive structural strength of the stone itself holding it together.
And there is a millisecond where that equation breaks. The pressure of the air simply exceeds the structural integrity of the stone.
The rock shatters.
Yeah.
And because it is still traveling at tens of thousands of miles an hour, the instant it fragments, its surface area expands exponentially.
Just instant fragmentation.
Yeah, and all of that incomprehensible kinetic energy is converted into thermal and mechanical energy in a fraction of a second.
It's not a chemical explosion like dynamite. It is the pure, violent conversion of kinetic energy into a blast wave.
Exactly.
And this detonation happened at an altitude of roughly 5 to 10 kilometers. That is 3 to 6 miles high.
Right at the cruising altitude of a commercial airliner.
And the energy yield from that conversion. The low-end estimates are 3 megatons, but many models push it up to 15 or even 50 megatons of TNT.
Staggering number.
Think about a 15 megaton blast. That is 1,000 times more powerful than the Trinity test that birthed the atomic age.
Right.
It is roughly equivalent to Castle Bravo, the absolute largest thermonuclear device the United States ever detonated. And it's a third of the yield of the Soviet Tsar Bomba.
A thermonuclear yield generated entirely by mass, gravity, and speed. No uranium required.
It is terrifying, and I love the ingenuity of how they proved this. In the mid-1960s, Soviet scientists wanted to physically model Chiba's fluid dynamics to see if an airburst would actually create the butterfly pattern Kulik found.
But they didn't have supercomputers.
Exactly, so they built miniature model forests out of matches stuck into wire stapes.
It is an incredibly elegant analog approach to complex physics.
They strung a wire at an angle over the matches, slid a small explosive charge down the wire, and detonated it in midair.
Right.
And when the smoke cleared,
The tiny matchstick forest was flattened.
into the exact same spread-eagled butterfly shape. The experiment proved definitively that the Tunguska object approached at an angle of roughly 30 degrees, detonated in midair, and directed its primary blast wave downward and outward.
But science doesn't just rely on matchsticks. Nature eventually provided the ultimate, undeniable, real-world validation of Chiba's airburst models exactly 105 years later.
The Chelyabinsk meteor, February 15, 2013.
Over the Ural district of Russia, a stony asteroid measuring about 20 meters across, so roughly a third the size of the Tunguska object, slammed into the atmosphere.
And because it was 2013 in Russia, the entire event was captured from dozens of angles on civilian dashboard cameras. We all saw the video.
Video is everywhere.
You see the blinding flash of the plasma trail lighting up the morning sky, and then silence. Because the light travels instantly, but the shock wave takes time.
And when that shock wave hit the ground, the airburst released roughly 500 kilotons of energy, half a megaton. It shattered windows across an entire city, collapsing roofs, and injuring over 1,200 people.
Chelyabinsk was the terrifying proof of concept. It proved beyond any shadow of a doubt that atmospheric airbursts of stony asteroids are a very real, highly destructive mechanism.
They behave exactly as the Tunguska models predicted.
You do not need a crater to level a city.
Chelyabinsk closed the book on how Tunguska exploded. But the source material reveals a massive, decades-long turf war in the scientific community over a completely different question.
Which is?
What exactly was the object that exploded?
Ah, right. Which brings us to the great debate. Asteroid versus comet. Because for a very long time, the comet hypothesis wasn't just a fringe idea, it was the reigning champion.
It started in 1930 with a British meteorologist named F.J.W. Whipple. He proposed that the Tunguska body wasn't a rock at all, but a small comet.
Okay.
And structurally, a comet is essentially a dirty snowball, an amalgamation of dust, water ice, and frozen gases.
And structurally, that makes a ton of sense for Tunguska. If the object is made of friable ice and frozen gas, it perfectly explains why Kulik never found a mountain of iron.
Exactly.
It completely vaporized because it was designed to melt.
It also elegantly solves the mystery of the bright nights we discussed. If a comet vaporizes in the upper atmosphere, it disperses its massive inherent volume of water vapor and ice dust straight into the thermosphere.
Oh, right, the noctilucent clouds.
Yeah, a 2009 study by Kelly and his team leaned entirely into this, directly comparing the Tunguska glowing skies to those space shuttle exhaust plumes. To them, water vapor equals noctilucent clouds, therefore Tunguska was a comet.
There was also a massive celestial coincidence backing them up. In 1978, astronomer Ubor Kresak proposed that the Tunguska body was a broken fragment of comet ink. Comet ink is the parent body responsible for the Beta Taurids, which is an annual meteor shower that Earth passes through. The peak of the Taurid shower is right around June 28th and 29th.
And the Tunguska event happened on June 30th.
The orbital trajectory of the impactor roughly aligns with a fragment breaking off from the Taurid swarm. The dirty snowball theory had immense momentum.
Then, in 1983, astronomers Denik Sekanina publishes a paper that stops the comet theory dead in its tracks. He brings the brutal physics of atmospheric entry right back to the forefront.
What did he find?
Sekanina pointed out a fatal flaw in the dirty snowball model. Comets are fundamentally fragile, porous objects.
Right.
If a fragile ball of ice hits the atmosphere at Mach 80 on a shallow 30-degree trajectory, the ram pressure would have disintegrated it almost immediately. It would have vaporized way, way higher up in the stratosphere.
The air is simply too thick down at 5 to 10 kilometers for a snowball to survive. It would be like trying to shoot a snowball through a brick wall.
Exactly. Sekanina argued that to penetrate that deeply into the dense lower atmosphere before detonating, the object had to have immense structural density. It had to be solid rock, an asteroid.
And the asteroid camp got a massive mathematical boost in 2001. A study by Farinella and Foschini ran orbital modeling backwards.
A really cool approach.
Yeah, they took the atmospheric trajectory and calculated the probable origin. Their models gave an 83% probability that the object arrived on an asteroidal path originating from the main asteroid belt, compared to only a 17% probability of it being a comet.
When you combine Sekanina's altitude physics, Farinella's orbital math, and the microscopic evidence of the nickel-rich spheres in the tree sap, the scientific consensus shifted heavily and decisively toward a stony asteroid.
But because astrophysics is wonderfully weird, the debate doesn't end there. In 2020, a Russian team published a model proposing a glancing blow hypothesis.
It is a fascinating mathematical exercise.
They modeled a 200-meter iron asteroid entering the atmosphere at an incredibly oblique, shallow angle. The model suggests the asteroid comes in, compresses the air to create the massive plasma shockwave that flattens the forest, but instead of blowing apart,
The angle allows it to literally skip off the dense lower atmosphere.
yes, it bounces back out into solar orbit without browning up entirely.
Like a stone skipping across the surface of a pond. It is a mathematically elegant solution to the no crater, no rocks paradox, but it requires an incredibly narrow, specific set of orbital and compositional parameters to work.
And if you think bouncing space rocks is a stretch, we have to look at the Earth-based theories. Because not every scientist looked up at the stars to solve Tunguska. Some looked straight down into the dirt.
The Verneschot hypothesis.
Proposed by astrophysicist Wolfgang Kundt. He argued that Tunguska wasn't an extraterrestrial event at all. He theorized it was caused by the sudden release and violent ignition of 10 million tons of natural gas bubbling up from deep within the Earth's
But
crust.
the mechanics of his theory suggest that a massive bubble of subterranean gas leaked to the surface, rose into the atmosphere until it hit an altitude of equal density, and then drifted downwind, acting like a colossal, invisible wick.
Right.
Eventually, this gas cloud found an ignition source, likely a lightning strike.
The gas ignites. The flame streaks rapidly back down the wick to the source of the leak, resulting in a massive volumetric detonation above the forest.
It's an incredibly creative application of geophysical principles.
But I have to push back hard here, using Occam's razor. Are we seriously supposed to believe that an underground gas leak perfectly mimics the visual of a glowing blue cylinder descending from the sky?
Well, it's a stretch.
That it creates the exact radial blast pattern of a high-altitude hypersonic airburst. And most importantly, how does a natural gas leak explain the extraterrestrial nickel-iron spheres and the iridium anomalies trapped in the tree sap? Doesn't the simplest explanation point firmly to space?
Your skepticism is entirely warranted, and it reflects the broader consensus of the scientific community. The Vernish-Shot hypothesis is firmly a minority theory because it fails to account for the microscopic chemical evidence.
Exactly.
However, it is vital to understand why these fringe theories are published. True scientific rigor requires testing all physical boundaries.
That makes sense.
When confronted with an anomalous event, you must mathematically test all energetic systems, both extraterrestrial and terrestrial, in order to definitively rule them out.
You have to prove why the gas theory is wrong to prove why the asteroid theory is right. Impartiality is the bedrock of the method. But yeah, the consensus is resting comfortably on the stony asteroid model.
Or so they thought. Because just when the scientific community believed they had comfortably ruled out any physical impact with the ground, an Italian team in 2007 threw an absolute wrench into a century of settled science.
This is hands down my favorite part of the modern investigation, the Lake Checo controversy. It proves that even 100 years later, the taiga refuses to give up its ghosts easily.
Set the stage for us.
Yeah.
What did the University of Bologna team find?
In 2007, this Italian team identified a small body of water called Lake Checo. It is located just 8 kilometers, about 5 miles northwest of the blast epicenter.
Very close.
And they publish a bold, headline-grabbing claim. Lake Checo is a 10-meter fragment impact crater.
It is important to clarify that they were not disputing the main airburst. They agreed the 50-meter asteroid detonated in the sky. But they argued that a dense 1 to 2 meter chunk of that rock survived the thermal disintegration, continued along the trajectory, and slammed into the muddy Siberian taiga, gouging out this lake.
And the evidence they presented was incredibly compelling. First, they looked at the morphology of the lake itself. Typical lakes in that specific taiga region are flat-bottomed bogs. But Lake Checo has a distinct, steep, conical shape. It looks exactly like a funnel, which is precisely the geometry of an impact crater.
They backed up the visual morphology with acoustic echo soundings and magnetic readings of the lake floor.
Oh, the magnetic anomaly?
Yes, and they found a distinct anomaly deep below the deepest point of the lake's funnel, a localized magnetic reading that strongly indicated a dense meter-sized chunk of rock buried deep in the sediment.
But the real kicker was the mud. They took core samples from the bottom of the lake. They found a roughly 1 meter thick sequence of normal stratified lake deposits overlaying a bed of coarser chaotic material.
And they argued that the transition boundary between these two distinct layers corresponded perfectly to the year 1908.
Exactly. Furthermore, below that 1 meter mark, they found abundant forest tree pollen, but 0 aquatic plant remains.
The implication being that prior to 1908, there was no lake there at all, just a swampy forest that suddenly had a hole punched into it.
It sounds like the ultimate smoking gun. 100 years later, they found Kulik's crater. You have the funnel shape, the buried magnetic rock, and the botanical transition showing the lake was born the exact day the sky exploded.
The media absolutely ran with this.
Oh, they loved it.
But science is a brutal, self-correcting crucible. Extraordinary claims require unassailable evidence. And the Russian scientific community pushed back with devastating precision.
In 2017, a full decade after the Italian claim, Russian scientists published a rebuttal that completely dismantled the crater theory. They went back to Lake Checo and they took their own core samples of the mud. But they didn't just look at pollen, they looked at the varves.
Let's explain varves, because this is where the geology gets beautiful. Varves are essentially the underwater equivalent of tree rings. In certain lake environments, sediment settles in distinct annual layers, typically alternating between light and dark bands, depending on seasonal runoff.
Right?
By simply counting these alternating bands of silt in a core sample, you can determine the exact minimum age of a lake bed.
And when the Russian scientists pulled their core sample and counted the varves, they counted at least 280 distinct annual layers, meaning the lake was at least 280 years old.
So it existed long, long before 1908.
But the Italian team could easily argue that the Russian team was misinterpreting the sedimentation rate. How did the Russians definitively prove that those 280 layers weren't just deposited really quickly during the chaos of the impact?
This is the AHA moment that absolutely floors me. They proved the timeline using radioactive dating, but not ancient carbon dating.
What did they use?
They used the radioactive ghosts of the Cold War.
It is a masterful piece of forensic chronology.
It really is.
In the mid-20th century, decades after Tunguska, the Soviet Union conducted massive above-ground nuclear weapons testing at an Arctic archipelago called Novaya Zemlya. Those thermonuclear tests lofted distinct radionuclide contamination, specifically radioactive isotopes like cesium-137 high into the atmosphere, which then spread across the Siberian landscape.
And over the years, that radioactive fallout gently settled into the mud at the bottom of Lake Checo.
It created an undeniable, chemically stamped timestamp in the sediment layer for the late 1950s and early 1960s.
Exactly. The Russian scientists found that specific radioactive layer of Cold War contamination in their mud core. By measuring exactly how deep that 1960s layer was buried, they could calculate the exact undeniable average annual sedimentation rate of the lake.
And they found it was accumulating at between 3.6 and 4.6 millimeters a year.
Which is less than half of the speed the Italian team had assumed in their 2007 paper.
The Italians assumed the mud piled up fast, which made the lake look young. The nuclear fallout proved definitively that the mud accumulated slowly, proving the lake was hundreds of years old.
It's amazing.
We literally used the radioactive fallout from Cold War nuclear weapons tests to solve a space rock mystery from 1908.
It perfectly encapsulates the relentless, rigorous nature of modern science. Geologists, physicists, and chemists used isotopic dating to cross-examine and ultimately defeat a flawed hypothesis.
Right.
And when you factor in Sekanina's atmospheric physics, the reality that a stony meteorite simply could not survive the Mach 80 ram pressure of the airburst intact while retaining enough kinetic velocity to dig a funnel crater that deep in, the Lake Checo theory collapses entirely. The lake is just a lake.
And so, the great mystery remains craterless. The planet healed the scar, and the evidence is nothing but microscopic ash and mathematical models.
Which is perhaps exactly as it should be for an event of this nature.
So, stepping back from the mud and the varves, what does this all mean for us today? As we wrap up this deep dive into the sources, you have to just sit with the awe-inspiring, terrifying scale of what happened.
It's hard to even picture.
On an otherwise quiet summer morning, a random rock from deep space, the size of a 20-story building, hit our atmosphere at 100,000 kilometers an hour. It released the energy of our most terrifying nuclear weapons, and it leveled a forest the size of a modern metropolis.
A footprint the size of Tokyo or New York, completely flattened in seconds.
And it did all of this without ever touching the ground.
It is a deeply humbling reminder of the sheer kinetic energy constantly floating around in our solar system. We exist in a cosmic shooting gallery.
We really do.
Statistical models suggest that an event of the Tunguska magnitude happens roughly every 300 to 1,000 years.
Every 300 to 1,000 years. We are well over a century out from Tunguska now. But here is the detail that keeps me awake at night. The terrifying role of planetary rotation.
Oh, this is the scary part.
That asteroid came from the dark of space, but the Earth was spinning on its axis to meet it. If that asteroid had arrived just 4 or 5 hours later, the rotation of the Earth would have placed a major European city, like St. Petersburg, or even an American city on the eastern seaboard, directly in the crosshairs of that downward blast.
Millions of casualties. It would have fundamentally altered the trajectory of human history.
But I want to leave you, our listener, with a final lingering thought. Something pulled directly from the deepest corners of the scientific sources we explored today, and it is deeply unsettling.
We spent a lot of time discussing the great debate asteroid versus comet. And while the modern consensus heavily favors a dense, stony asteroid, let's look back at the comet Inca theory for a moment.
Okay.
Specifically, the idea that the Tunguska object was a fragment hiding within the Beta Taurid meteor swarm.
Right. The debris field that we physically pass through every single year in late June.
Exactly. If the Tunguska object was part of that swarm, it means it wasn't a lone, random wanderer. It was part of a family. And astronomers take this threat seriously enough that they are actively searching that specific debris field today. In 2019, major observatories conducted targeted searches looking for hypothesized asteroids roughly 100 meters in diameter, twice the size of Tunguska, hiding inside the Taurid swarm.
We pass through that cloud of cosmic debris every summer. We sit on our porches and we watch the beautiful shooting stars burn up in the atmosphere. But what else is hiding in the dark of that swarm, waiting for its turn to hit the atmosphere at Mach 80 and light up the sky?
It forces you to look at a summer meteor shower with a healthy dose of existential dread, doesn't it?
It really does. It brings us right back to the beginning. We desperately want the universe to be predictable and measurable. We want the clean X-ray showing the broken bone.
We want the giant crater.
Exactly. We want the undeniable crater showing the asteroid impact. But Tunguska proves that sometimes the most catastrophic events don't leave a footprint you can touch. They just leave a terrifying, invisible ripple in the air and a reminder of how fragile we really are.
Well said.
Thank you for joining us as we unpacked this incredible piece of history. Keep questioning assumptions, keep looking up, and we'll see you on the next deep dive.